So, so now I am going to touch one topic called step and impulse response. Not using Laplace but using differential equation, because this is the most important part. Not using Laplace. Okay, that's the chapter number 6. Till now you have not learned Laplace. I should assume that. Okay. So same book. I am following this first book, and all the things has been copied from page number 111 to 126. Okay. So the numericals and all these things I drop them so that I can cover the things in like 50 minutes. Okay. So do you know the difference between all these inputs? Yes or no? Is there anybody who doesn't know step, response, impulse, and sinusoidal? What is step? Step response is this one, right? I can mimic this using this one also. The input is step right now. Can you see that? At t equal to 0 minus, the switch is off. At t equal to 0 plus, the switch is on. So it is from 0 to 1 volt. That is what I am giving as an input. So that input is known as a step input, right? What about impulse? Sharp peak. So where? Infinite or I'm not asking like delta direct, but in general impulse, not by direct. Okay. So yeah. So this time is very small. If it is tends to 0, then we draw this one, right? So it's a delta of t, right? Then it becomes delta direct function, right? By the gentleman called Dirac. He gave this definition, right? Otherwise, this impulse is this one. This value may be anything. It may be some finite value, right? Okay. Everybody are able to hear me? Sorry. Hello. Yeah. So generally, why this is very important is if you are talking about, let's assume that you talk about square wave. When you are drawing this, it looks like this one. But maybe in a laboratory, when you are going, it looks like this one. If you zoom in, you will find that your square wave is not square wave, but little bit ramp and then the high value and low value, right? So when I'm taking the derivative of this one, so this part, what I'm going to get? Derivative of this, let's call this function as v of t. What are you going to get? Constant. Can I draw something like this? So this impulse function has invented, and it is very useful for this case that the derivative of step response is actually impulse. If you forgot, then I'll tell you d by dt of step is equal to impulse, or the train of impulses, right? So that is what we are going to use it to find out the things in our circuit. Do you remember how to find out I 0 plus I derivative 0 plus? You remember last time we did it, right? If there is a circuit which looks like this one, and I'm applying here delta of t, which is in the form of current, then what will be I 0 plus? Assume that this is V. Hmm? You remember? So what is happening at t equal to 0 plus time to capacitor? It's open or short? Why? In terms of current, look, not in terms of voltage I'm talking. If you remember last time we did it, and in terms of current it gets short at low frequency, if you remember. In terms of voltage it's different. That's why I'm teaching in terms of current, because it is not known to everyone and people make mistake, right? So it's reverse of that. At t equal to 0 plus, in terms of current, this capacitor becomes open circuit, right? Anyway, so let's go to the circuit, which looks like this one, right? So as I told you, this is also copied from chapter number 5, network analysis, and at page number 111 you will find this figure. Okay. Okay, so I can write down following things. In terms of voltage, not in current, in terms of voltage, Vc0 minus is equal to 0. Is there anybody who doesn't understand this one? Akshita, do you follow? No. So do you know about capacitor? So what is the impedance of capacitor? 1 by j omega c. So what is happening at 0? If time is 0, time is 0 is low frequency, right? So if frequency is zeros, and whether this will be open circuit or short circuit, open circuit, right? So voltage will be 0. There is no voltage across that. That is what I am calling it 0 minus. At 0 plus, I am looking at high frequency, where I want to see what is happening to my output at steady state. So I am looking at high frequency. So in that case, capacitor will be short, right? So in short, if it is Vc0 plus, what can you tell about Vc0 plus? This is voltage. Hmm? Yeah, it's short circuit, but by looking at this circuit, can you tell me the equation? Because these two things will be useful, right? Initial and final condition will be useful to solve any equation. Hmm? Hmm? Sorry? This is what you are saying. Yeah. But at that time, this I t has to be I0 plus also, right? It cannot be just t. It will be I0 plus. So that you need to keep and you need to find out. So this was just a little bit of brushing up what we have studied in last lecture. So if you forgot that, I request please go through the lecture which I am going to keep today. Right? I could not keep that lecture online last time, so we'll keep it today. So V of t is nothing but delta of t, which is I am giving as an input, which is impulse right now, is equal to r of I of t plus 1 by c integration from 0 minus to t. If you like, you can go from minus infinity to plus infinity also, but our interest of time is 0 minus to 0 plus actually, right? So I of tau d tau, no problem, right? Now what is happening next? Because we want to solve this equation so that we can find out what kind of response we are going to see. So right now what I am doing, I know that I can solve this differential equation which does not have any integral. So the trick is, let's remove the integral part. So what I am doing, I am assuming x prime t, which is derivative of x divided by dt, is equal to I of t. Then this entire thing will be 1 by c times x of t, right? Just to make things easier, and which is like x of t is some variable, just a variable, right? Like in your differential equation, you are keeping somewhere lambda, right? In our book, this Franklin Kuo, they are using p. Instead of lambda, we are going to use p because this book is following p everywhere, so I'm going to use that one. Although I'm also using lambda generally, but we are going to replace with p. So once you have this one, you need to write down the differential equation in terms of characteristic equation, where you are replacing this derivative things with some variable, right? But before going to that, x of 0 plus is equal to 1 by r, which we already found out, right? X of 0 plus is equal to 1 by r by looking at this condition, because this is short circuit, right? And this x is in terms of current, it's not in terms of voltage. So of course it is going to be short circuit, and this is going to be 1 by r, right? Now I can write down same equation. This is same equation, and this is called characteristic equation, which I am going to define it as h of p is equal to r times p plus 1 by c, where x of t is, you used to write down lambda, but they are not writing lambda. This author is writing p, right? So rp plus 1 by c. So can you find out this equation solution? This kind of differential equation is known as linear, by the way, right? If you remember. So if it is first order, it's linear. If it is more than first order, it's non-linear. So now what will be the solution? P, you need to take it one side, and right, you need to keep this one equal to 0, right? In that case it was 4, right? But right now it's 0 in this case. So what will be the solution? Minus 1 by RC, right? So if it is minus 1 by RC, you know that the solution of such system whose solution is minus 1 by RC, if it is happening at only at one place, right? If it is like this, the solution is different, but for this case the solution is e raised to minus t divided by whatever the solution you got it, right? Times initial condition, times initial condition. If you remember, you used to write down C1 times e raised to minus t by RC, right? And when it's multiplied by u of t, that is what the input, right? Are you following? Huh? H of p is characteristic equation. That's the definition of characteristic equation. So you are making this equation, which is simpler right now. How do you solve a differential equation in your maths? If I am not wrong, if it is, let's assume that d square x of t divided by dt square plus e by dt x of t plus 2 equal to 0. You used to write down something called characteristic equation, no? Right? So characteristic equation is equal to lambda square plus lambda plus 2 equal to 0. This entire thing he is calling h of p, but instead of lambda, he doesn't like lambda, so he writes e square p in terms of p is available, right? Are you following this, or is it too much? Okay, so if that is the case, you are going to, okay, when you are solving this, like the equation which I wrote there, so it's p plus 2 p plus 1, right? So there are two solutions, p equal to minus 2 and p equal to minus 1. So there will be, answer will be e raised to minus 2t plus e raised to minus t, but you will have some initial conditions c1 and c2, right? So c1 and c2 needs to be known in our case, and that can be found out only using fact that what is happening at t equal to 0 plus and 0 minus time, right? So we already found out at 0 plus it's 1 by r. That is what I am going to keep it here, 1 by r, that is the x at 0 plus, because I am interested in steady state, right? So that is what here, times e raised to minus t by rc times u of t. U of t is known as unit step, right? Unit step response. So it's going from 0 to 1. That is the meaning of u of t. That's why they write u rather than s of t, right? Okay, all good till now, right? So now what you need to do, just go back to our original equation, where what we have done, x prime of t is equal to I of t. That is what we assume, right? If you replace that and if you write it down one more time, delta of t is equal to r times, I should go back and here. So delta of t is equal to r times I of t plus 1 by c integral 0 minus to t I of tau d tau, right? So that is the time from 0 minus to t, right? If you keep I of t one side, then you are going to see such thing. Just it's playing with this equation, right? Are you following this, right? If you follow this, then you must have derived such equation maybe in past in terms of v, but I'm deriving everything in terms of t I because I is sometimes difficult. Okay, if you know such things, there are two things are available. One is 1 by r times delta of t, and one is 1 by r square c e raised to minus t by rc times u of t. So when I'm drawing the impulse response is nothing but this one, right? I of t. So which has one function which is 1 by r times delta of t, which will be only one impulse at particular time where t equal to 0, right? And another is minus 1 by rc at t equal to 0. It starts from minus 1 by rc and it keep on going in reverse way, right? E raised to minus trc, but it's in minus, so it will go this side. Addition of these two is equal to, that's the answer, or that's the solution, right? Similar to that, if it is step response, now can somebody can explain this step response? Sorry. No, how to find out step and impulse, by the way? What is the difference between step and impulse? So step response is u of t. If you take the derivative of this one, you should get impulse response, right? In terms of time. So that is what you need to do. Sorry. Right? If you have some difficulty, I'll solve some of the questions, then you will understand, maybe. Right? This is just for starting, right? Okay. But if it is voltage, look, till now whatever we were drawing here, these are the currents, x of t, I of t, all these are the impulse and step response for current. But for the case of voltage, it's going from I0 divided by C and going down. You need to solve this. Okay, I'm not solving this. This is given in book. Right? This is, again I'm telling, this is a revision. This is what I'm expecting so that I can build up something on top of it. Okay. Okay. So when you are going to draw the real response, then you are going to see the total response is equal to starting from 0 and moving towards I0R. That is what you are going to see. You must have seen this one, right? If it is step input, the output looks like this one. This is happening because of our equations, which is nothing but u of t 1 minus e raised to minus t by rc, right? So just this will be subtracted from minus, so e raised to minus t by rc will look like this one, and for 1 it will be subtracted from 1, so it will look like this one, right? Okay, let's look at this circuit. Now can you try to solve this for impulse and step? So technique says that you have to write down the equation. Right now what I am giving is impulse. Can you see this? Whenever you are saying some switch, it's impulse. Sorry, it's step, right? It's a step of current I am giving. So in that case, can you write down the equation which is already written at the down, right? So I0 times u of t, that is what the input is equal to G is transconductance is equal to 1 by R times V of t plus C dV by dt. Yeah, yes or no? Right? If you know this, you can write down the characteristic equation directly. Look, right now I have not assumed something like x of t in between. If you remember the last example which we have solved for a simple RC circuit, I assume x prime of t is equal to I of t. But right now I am not assuming because there is nothing like uh, integration sign in this equation. It's all derivative, right? So you can find out direct step response without having any difficulty. Yeah. So can we write down the characteristic equation for any differential equation which is linear, which has only one differential, right? So now can you tell me what is going to be the solution for V of t? Hmm? What you are saying? Minus c by g or g by c? Minus g by c, right? Answer will be always 1 by RC. Most of the time answer is known to us, but we are going through differential equation. Okay, but here the only thing is my input is not 0. If you remember last circuit which I have used, RC circuit, the input was this one. Right now whatever circuit I am using, the input is this one. Can you identify these two things or not? Look, here there is a switch, so Ig of t is available after t equal to 0 plus time forever. So it's a step response. But for this case, if you identify this one, where is the circuit? Here it's delta of t, right? So it's impulse. Delta of t is impulse. So the input was impulse. Here input is not in impulse, but the input is step, right? So at t equal to 0 plus time, here t equal to 0 plus time, the input was 0. At t equal to 0 plus time, the input is 1. Treat all these numbers as normalized number. Okay, they are not in terms of voltages and all, right now. Are you following this? Is it difficult? Or because sometimes people make mistake when we are going to keep difficult circuits, then it will be more complicated, right? So this is a simple difference for both of them. Now this equation now looks like the one which I wrote it there, because in the earlier case you only need, so if you see some equation which is some, let's assume that function of some derivative is equal to 0, then you don't need to find out particular integral, right? But if it is not 0, but if it is equal to something, it might be anything, then the solution is equal to whatever you used to write down, e raised to minus lambda 1t plus e raised to minus lambda 2t is plus something called particular integral, right? This is similar to what we have studied in Bode plot, right? If all the solutions are real, there is no problem. The answers will be e raised to minus lambda 1t. If all the solutions are real, but if they are not real, you are landing up in sine and cos because it will be imaginary. sine plus j times cos, right? Sorry, cos plus j sine, right? So do you remember how to find out particular integral for this case? Hmm?
It's like 4 upon d plus 1 upon d plus 2.
Okay, nice. So Akshita is saying if it is 4, then
4 upon d plus 1 into d plus 2.
what is d?
So like in a form of differential.
Okay. So derivative of 1 plus 2. What is 1?
So d will be
Capital D.
D.
Okay, sorry. So I'm not good mathematician. D.
D plus
d
1
plus 1
bracket में और bracket में D plus 2.
How did you find out this? D plus
so
1 D.
by then it will be 4 upon bracket 1 upon d plus 1 minus 1 upon d plus
Okay.
2.
Maybe I will tell you my technique. What circuits designers are doing generally. So I forgot what you are saying. What we generally do, you need to find out the particular integral for the force system which looks like this one, alpha times e raised to beta t. For our case it's 4 times e raised to 0 t, right? So in general it's alpha times e raised to beta t. Then the solution is equal to alpha divided by h of beta, where h of beta is your characteristic equation, for which Divyansu was asking me what is h of p. Same, instead of p, beta will be substituted that. So in this case it will be 4 divided by,
So the same thing.
yeah, same thing. Okay, so you are solving this equation and then you are saying okay, right? So everybody knows about this technique, right? So if you remember that, very good, no problem, right? So you need to find out two things. One is called, for this case you need to find out root using the characteristic equation, which is minus g by c. So it is equal to e raised to minus g by ct, right? And you need to find out the initial condition that has to be found out. So what will be the initial condition? So just you need to make some short circuit and open circuit and you have to find out. By the way, this is what I was talking about. This is particular integral, right? So it is equal to v of t k e raised to minus t by rc. K is right now initial condition, plus I0 r times u of t. I can understand beta in this case it will be 0, right? That is what I told just now. Where is that? If it is 4, let's say differential is equal, equation is equal to 4, which is written on the board, right? So 4 is equal to 4 times e raised to 0 t. So beta is 0 now, right? So here in this case, this is alpha I0 r times e raised to 0 t. That's why I'm calling this accordingly, right? So sorry, r, this is the solution, but the input is I0 times u of t. So it will be I0 times e raised to 0 t, right? So I0 divided by h of 0. So in this characteristic equation, replace p with 0, which will give you only g. So I0 divided by g, that is equal to I0 times r, right? That will be the particular integral. And what you are seeing here, it's complementary solution. This is particular integral. The only one thing which needs to be found out, which is nothing but the initial condition. Can you find out initial condition and let me know what is going to happen at v0 plus, right? To find out k, v0 plus. Okay. In terms of current, you need to see.
Sir, in terms
it will be open. So open means V by R. That's the current you are seeing, because you need this side current, not voltage. This K has unit of current, right? Right. So in that case, this is only I0 times R. That is what you are going to see in this circuit. Okay, when it's in shunt. So this is open circuit. So current through this network is equal to I0 times R. Right. So that will be indirectly the value. Sorry.
Minus I not.
Yeah, minus. So it will be another side. Yeah. Right. It's all about mathematics. How you are solving this. The main thing is how to find out the initial condition and final condition. Right. That you need to replace. And V of t is equal to I0 divided by C times. So can you see? By the way, what notation Franklin Covey has used has some problem. So those are not the correct one.
Sir,
Hmm.
that K we found out with RE 0 plus 2.
So it is open, right? So
It has unit of voltage.
yeah, sorry, my mistake is it has to be I0 times R, which is voltage. But we are looking for current, right? In terms of current. Yeah. Okay. So if you replace all these things, you'll find out I0R will be another side and 1 minus e raised to minus t by RC times u of t. But here, whatever we have found out, this is impulse. Sorry, this is step. I need to find out impulse. So how to find out impulse? Taking derivative of this equation. By the way, don't look at this Franklin Covey's notation. They are wrong notations actually. I should say it has to be v of prime of t. Right. If you solve this, the first part is zero already. Right. First part is zero. The second part is equal to I zero. Do you want me to solve this, or if you want, I can. Yeah. Yeah. Okay. So this is again graphical representation. One is a v of t is step response. In that case, one was starting from minus I0 R and one was starting from e raised to minus t by RC. Right. So both has to be added. So one is I0 R component and one is e raised to minus t by RC, but starting with I0R, right? The first part and second part. When you add both of them, you are going to get the answer, right? Okay. Okay. The next thing is, but if sometimes what happen, impulse you are not giving at t equal to 0. You are not giving such kind of impulse, but you are giving impulse like this. Time t equal to t. Then your response will not look like this one, but your response will look like this. Right? Is it too much or are you following? Yeah. What's your name? Sorry.
Himanshu.
Himanshu. Okay. Himanshu, are you following? Or is it too much? Okay. If you're following, then let's look at the new thing, which is now I'm not going to make the system with impulse or with step, but I'm going to use another thing which is sine, right? Which is very popular thing. We are not going to give just impulse and step, but we are going to give some other value of input, which is sine wave. So sine wave is written as a0 sine omega t times u of t. So how to solve this one? Such kind of equation. Look, input is changing, circuit is remaining same, right? Earlier times one was series, now we are talking about shunt. So this has solution of minus g by c, no problem. Initial condition you already know, and final condition is already known to you, right? So K is equal to 1 by R, right? I0 times R, sorry, right? Now you know all these things. Already this side is not difficult. The difficult part is this side. So do you know how to solve such kind of equation?
So we can convert it into
E power, yeah, right? If you are converting in e to the power, right? Divanshu, can you tell me what will be the equation? Is it correct, or I'm writing what he is saying? Okay. If it is correct, then you can solve this using what I told just now, the technique which I am using, alpha 0 times, right? So the answer will be alpha divided by h of beta, right? You can solve this. It will give the same answer what Akshita is solving, right? It's same answer. Okay. But generally, when we are doing this, the answer, I can tell you another way of looking at this. We don't do this way. We are finding out the magnitude times sine omega t, and because of this entire network, you will have some phase. In reality, this is going to happen with your circuit. That when it is transforming from RC, the magnitude will change and this phase will change. Earlier it was zero, right? So now let's solve this equation. So characteristic equation is equal to Cp plus G. Solving this is going to give me minus G divided by C. So Vc of t is equal to K e raised to minus Gt divided by C times U of t, right? Now I am finding out the particular integral. It is similar to what I was talking to you. The magnitude and this will be phase. Let's look at that. So writing the equivalent impedance, what we are going to see, right? So what will be the magnitude of this impedance function? Magnitude. Yeah. What about the phase? Minus 10 inverse. Hmm? Very good. Okay. Can you see same thing? Right? It's minus 1 by 2. I am keeping here plus 1 by 2. In terms of like this was impedance function, right? So it has to be multiplied by current to get the voltage, right? So that is what you are going to get it in a particular integral. But you can solve using your technique also. You will get the same answer, right? Through complex number also you can find out. Right? Okay. Now for a zero initial condition, means I'm assuming that zero initial condition v0 plus equal to v0 minus. I'm solving this equal to 0 and I'm finding out all these equations, right? Just for sake of finding out k. So right now we assume that capacitor is not charged at the initial time, and then we are finding out what is happening to find out k. Other way around, you can also follow what I told you. You can keep that and you can find out value of k, and that will give you the solution. Are you following this? Okay. Is it too fast, or because I need to tell you about RLC before we leave today? Right? So you follow the procedure. You have to write down the equation. If in equation you are seeing somewhere integral, then you have to assume some intermediate variable x of t, and you have to see only derivatives. Once you are in derivatives, you can solve through differential equation, and you have to see what is happening, whether your input is impulse or step or sign. If it is impulse, there is no problem. The solution is very easy, e raised to minus p times t, right? But if it is step or sine wave, you need to find out particular integral using this solution, right? Yeah. When you are doing this, you can find out all the required solutions, right? Okay. But if it is RLC, which is more like important to us, so in that case, the right now the input is what, impulse, sine, or step, right? So the input is step because there is a switch. Whenever you are seeing a switch, there will be step input, right? At t equal to 0 plus, there is a value of one normalized current value of 1 will be available. So you can write down the equation, which is C dV by dt plus GV plus, right, with initial condition. Now you are seeing some integral, so you need to replace that with some other thing, or maybe you can take the derivative. So I took derivative of I prime of t is equal to C v double prime times t, and all this equation, and you can find out the roots, right? Now the interesting part happens, and you must have seen such kind of things in the last lecture of my Bode plot. If you remember, in Bode plot, the last lecture was complex and conjugate pairs. So now if you are not controlling R, L and C value correctly, you are going to see the complex and conjugate pairs. So what I am saying, if the answer is real, there is no problem. The solution of h of p, which is characteristic equation, if b is real, there is no problem. The solution is this one, right? But if it is not real, but if it is 0, that might be also the condition. If b equal to 0, then also no problem. You are going to have two roots at same place. If it is two roots at same place, how to find out the solution? First is k1 times e raised to minus at, where a is the root, and another one will be, right? Yeah. So you keep those things and you can get the answer. But the problem occur when both that b is imaginary, right? The solution has minus a plus or minus something j times b. This is what we have seen in the case of Bode plot, right? When this is happening, then output will have sine and cos, and your output will have some ringing, right? This kind of system is known as overdamped, and this is only happening when your system has complex and conjugate pairs of roots. The same thing I am telling you in a different way, right? In Laplace we already talked a little bit about that, right? This kind of system which has b equal to 0, it tries to settle without having any ringing or one ring. Such kind of thing is known as critical damped, critically damped. And this one, which has solution, this is always settling, so it's called, sorry, I made a mistake here, it has to be underdamped because its system is damping. In this case it's not damping, so it's called overdamped. The answer will be always like this, right? And this is always stable system, first one, right? You need to look at the where the poles are or the roots are available, right? first pole is inside UGBW and others are outside UGBW, the system is stable. You will not see any kind of ringing. No problem. Right? Is it okay? So can you submit the surprise quiz to my TS? So look at the solution, how you did it. And if you want to like submit the correct solution now, you can do that also. Can you do it in 2-3 minutes? The correct solution, right? Yeah, for this one only. 3 wale ka, 4 wale ka, whatever. Just whether you understand or not, that is more important.